This board was brought in for water damage issue, and under normal circumstances, whenever you have water damage, the first thing you will do is to discharge the motherboard by washing with some solution. So after washing with those solution, we plug in our charger and discover that firstly 19 volt was not switching and there was no short at the CLR. So the first thing I did was to cross the 19 volt voltage here. This is the switching MOSFET here. The first thing I did was to cross the voltage before doing anything here. So after crossing the voltage, the motherboard was consuming around 0.20 on the DC supply, and that is a clue for me that the standby IC is getting heated. Basically what I'm trying to say is wọ́n gbé bọ́ọ̀dì wá fún repair and wọ́n dẹ̀ ní omi ló dà sí. First thing kí èèyàn máa kọ́kọ́ ṣe fún issue yẹn, èèyàn máa kọ́kọ́ need àti discharge bọ́ọ̀dì yẹn by pé ká fọ̀ pẹ̀lú some solutions. Lẹ́yìn tá a fọ̀ tán, a discover pé 19 volt ò switch látara MOSFET due to pé gate value ẹ̀ ó wrong, kò ṣáà switch. But the best thing fún troubleshooting sake, kí n tó padà wá sí ibà tó lè jẹ́ bọ́ọ̀dì yẹn ti kú, in order not to waste my time, mo jump voltage mi first so that màá lè ní voltage ní CLR mi. Lẹ́yìn tí mo jump tí mo ní voltage ní CLR, ó ń consume 0.20 there about 0.90 0.20 lórí DC supply. Tí yẹn dẹ̀ ń try àti sọ fún mi wípé based on experience pé standby IC mi òun ló ń hit. This is my standby IC here. Check what is the impedance of these two coils. After checking the impedance of the coil, I found out, if you notice this one, although the board has been worked on and everything has worked, if you notice I worked on this part. So I lifted this coil to check where the short is coming from. Is it from input side or the output side? This is the input side of the IC and this is the output that happens to be the destination of the section. So after that, I discovered there was a short at this 1.8 section here because 5 volt is feeded here as power to this section. So there was a short on this section. This resistor was completely short, and at the same time it affects this IC. After changing this and this, these are the, this is the 1.8 regulator IC, and this is the 100 ohms resistor that was short. So basically government trial sọ ni wípé lẹ́yìn tí 19 ti cross tán, I discover pé standby IC ń hit. Ìgbà tí standby IC tó jẹ́ ilé tó ń hit, next thing ká ṣe ni wípé a change IC due to the fact pé VH3 and VH5 condition kò wá okay, impedance wọn gan náà low. So a change ẹ̀, lẹ́yìn tá change ẹ̀ 3 volts VH3 and VH5 méjèèjì wá, but yet this output always voltage kò wá. So next thing I check impedance méjèèjì, but impedance eléyìí ó low. Nígbà tí a rí ó low, kí la dẹ̀ máa ṣe? A lift coil yìí láti separate destination àti input ẹ̀ kúrò, that is IC part àti destination ẹ̀. Nígbà tí a lift, a discover pé destination ní short wà, a inject voltage síbẹ̀. Nígbà tí a inject voltage síbẹ̀, a discover pé this 1.8 regulator IC yìí ni issue wà àti resistor yìí náà ó ń warm. So 100k ló yẹ kó jẹ́. A change the value resistor yẹn under microscope, òun lélẹ̀ excuse me, òun lélẹ̀ yìí under microscope. So I change it náà. Lẹ́yìn yẹn 1.8 jáde. Ìgbà tá a dẹ̀ tún test yẹ, ó kọ́ improve ni. After testing, by the time we replace these two components, it only improved by consuming 0.13 on DC supply, 0.13 on DC supply. And for the fact that it was consuming 0.13, it means the board has improved, but still yet the board has not worked completely. No V-core voltages and other voltages were generating as at then. No V-core voltages, these two voltages were not generating, and other coils voltage and this 1.05 was generating. So the next logic gate yẹn wà. Come to this part of the board. Okay. Ibi báyìí ni logic gate yẹn wà. a discover pé pin number 1 yìí òun ló yẹ kó gbé VR on jáde, but it's so unfortunate kò gbé VR on jáde due to 1 or 2 reasons. So the only thing tí mo ṣe, mo bypass 3 power ó dẹ̀ display ó dẹ̀ take good consumption. So to explain the VR on part clearly, let me come under the schematic here. So this is the schematic of the board here, and VR on tó gbé wa wá sí ibà. Let me go to the VR on part first. Copy, paste. This is the VReg and this is the V core IC here, and this will number 7 of this IC. There is a little confusion in this schematic. It was splitted here to be 1, 2, 3, 4, 5 pin. This is another 5 pin again, 1, 2, 3, 4, 5, making 10 pin. But this is wrong. Pin 4 here is also the same thing as pin 4 here, just that we have 2 logic gates in it accepted, but pin 4 here is also pin 4 here. Pin 8 here is also pin 8 here. So this is just one pin. This pin 8 and pin 8 here, they are single pin. Pin 4 and pin 4 here, they are single pin. 5 and 6 are different, 3 and 2 are different, 1 and 7 are different. So that is it for that section. And tí eléyìí bá máa release VR on yìí, tí bá máa release output, is a logic of the presence of these following signals. But gbogbo signals yìí ló ń wá, still yet kò dẹ̀ release output. Torí tí gbogbo signals yìí bá wá, all these power goods are coming from all these regulators. Tí gbogbo power good yìí bá ti wá completely, a ti confirm all these power goods were coming. Tí gbogbo power goods yìí bá wá. Now I will retest the motherboard and let's see. So we've changed 3 components and made just a single jumping. So now can sit body can watch on test kájọ. It's a nice case study and tough one to be precise, but still once you understand what you are doing, it becomes very simple. Okay. This is a bent signal. Let me straighten this signal cable. Okay. I need it zinc. I need my RAM. Where's my RAM? This is a very useful device that I've built here. This is my DC supply, because all these normal DC supply, they have no adapter, and their connector, they have no adapter ID signal. So I've sacrificed a charger and a multimeter to be working on boards like this. So if I want to test this now, I'll use this instead of my normal DC supply. This is a very useful device here. Now the board has powered. Let's check the display. Now this is the display here, despite all we've done on it, and the board is now working perfectly. This is the current all this consumption I've been talking about. Ibi tí mo ti ń relé mi ò lo original DC supply, mi DC supply tí mo build tí mo lò ni, and it has been so helpful when I'm dealing with HP motherboards. So I can repower this again. Okay, power, and display have come. All right, thank you. Oniru ṣe ọlọ́bẹ̀ ṣe àwọn ọmọ mi á ní bọ́ yẹn máa ń sọ ọ́ kọ́ nìyẹn.